Hello everybody, I'm Nick, and in this video I'm going to answer a very simple question. What does it take to create a mocking framework in .NET Core? Or .NET in general, it doesn't really matter. Every single one of us for writing unit tests are almost definitely using a mocking framework, so we can mock different dependencies that we don't want to use in the code when we're testing. It's a cool concept, but have you ever thought of what actually happens behind the scenes? So I was curious about that, and what I want to do is, without actually looking at the code, I'm going to try and create something that will effectively work in the same way. And I think I have a plan, and I want to talk you through my plan, and I am going to try and attempt that. I think this video is helpful because you can actually see a practical example of using reflection, and I will also talk you through the process of tackling such a tricky issue. So if you find that of interest, please keep watching. This video is part of my I don't really know what's going on series, and if you don't want to miss any episodes, please subscribe and click the notification bell to get notified when I upload a new video. So first, let's take a look at what I have here. I have this mock library project, and it only has a single class, and that class is the assembly compiler. Now, this class actually is pre-written by me for a different project, and the only thing that we need from this class is this compile method. This method accepts source code, like C# source code in text, and an assembly name, and then it creates an assembly out of that because it will build a syntax tree, use a Roslyn compiler to compile it during runtime, and then return the assembly. And the only package needed to do that is, if I go to packages, is the Microsoft.codeanalysis.C#. So that's the only external package that our library will be using. And please keep in mind that this will be something very basic, like just mock a parameterless method without doing any other check. Or maybe we can add a few parameters, but we won't check for the parameters. Just so we can prove that we can actually do this. You can find this code in the description down below, by the way. So I'm going to close that, and I'm going to go to my test project, which I'm going to write a simple test. And this will validate the look and feel that I would like my mocking framework to have. So what I'm going to do is I'm going to say new mock example equals new my mock. That's what my mocking class will be named. I'm not going to use mock because you might confuse it with the library mock. And I'm going to say example here, whatever. We're going to make this later. So this will be an interface. And that way we're going to create our mock. And then on the mocking step, I want to do something like mock example.mock method. And this will be our example class. And maybe we're going to have an example method. And we're going to comma here. And we're going to say hi from my mock. So something like that. And this is how we're going to register what method we want to mock in the interface and what it should return. So this would actually return a string. And at the last step, maybe actually in the act, we might want to have the example, and this will be the class. So mock example should have an object method, which will return the object we just mocked. If you're familiar with mock the library, you'd know how this works. And at the end, we're just going to say example method, and this will actually return hopefully this. And because I'm not using Closant assertions, I'm just going to say assert equal, and the first one is the expected and the next is the actual. So expected is this, and that's the actual. So that's what I want my mocking framework to look and feel like in a very basic form. So the first thing I'm going to do is I'm going to go ahead and create this example interface, and I'm going to stick that method in there just so we can have the compiler feeling happy about this. We're missing this example method. I'm going to go ahead and say string example method, and that's it. And then I'm going to create this my mock class. So let's go to the mock library, and I'm going to create that my mock class. So now that we have this my mock, as you can see here, we have the t-type parameter, which is what we actually are going to be mocking. And I'm going to say t mockable here. Nice name so we can know what it is. And I think where t mockable is a class, I think it should be a class. Yeah, I think this will limit it, because if you put a string there, I don't think you can really mock a string. So that is fine. And we have two things that we want to create, the mock method and the mock object. So let's see how Rider creates that, or if it's even usable in that form. Okay, I mean, close enough. So what I want this to return is that my mock of type tmockable, because you might want to chain a few of these methods. So it's going to return itself. This is the return value, which actually shouldn't be the string. It should be a t returns or returned at the result. Okay, so this is the result, and we should put that here because that's what we want to return from the func. And also this should be the tmockable. So that's more like it. We just have to put tree result here. So yeah, that makes sense. And here is where we actually gonna register the method we want to mock, but compile. Yeah, so this is happy with this. And the other thing is the object, which will actually be the implementation. So the tmockable, which will materialize during runtime. So public tmockable object, and we'll see how that will be implemented. For now, throw not implementation exception. Oh, you don't like this, do you? Yeah, because I'm returning it. God damn it. Oh, I have to. Yeah, I know this language, trust me. Fine, so that's the look and feel of our library. And what I'm going to do, what's my plan here, is the following. So I have 3 steps. We're gonna store all the mocked methods in my mock. So we're gonna make a dictionary to store them, and that's the description of this action. Then I'm going to compile, actually write the class or a class in string form and compile it. And that will happen during runtime. And the last step is to just attach the behavior to the class. So we're effectively creating an in-memory proxy implementation of this iExample interface. And to help you visualize this a little better, and to help me visualize it a little better, I'm going to create an example proxy. And this will implement iExample. So I'm forced to implement this method because this is an interface, and you have to implement methods in interfaces. Now, I think that the way this will work in this proxy is that this proxy will keep a private read-only, not func, but probably dictionary of string, which is the name of the method you're invoking, and then a function that accepts no parameters because we're going for a very simple version, and returns an object, so some sort of object. And these are the method interceptors, and we're going to initialize them from the constructor. So this looks fine to me. And then you have to implement all the methods that the interface has. So we're going to write something that checks for that and implements it. But the implementation of every single method that we implement, that we're forced to implement, will look like this. I think we're going to have a result, and then we're going to have an intercept method, and then we're going to have the name of the method here. I could use name of, I think, but let's keep it like this for now. And then we're going to have to somehow cast it to the thing that's being returned, because intercept method should return an object. Let's see how this would look like. Maybe public object intercept method. Let's accept a string, which is a method name, and this returns method interceptors. You get it from, actually we have to do 2 things. First, we need to check if method interceptors doesn't contain key. So if the method is not actually mocked, then throw new not implemented exception. But if it is, you want to get it and you want to invoke it, and then just return the object. So this method will need to be written in every single proxy class that I make. And that's the minimum level of implementation that you want for your proxy class. So what do we have? We have using statements, which we have to retrieve based on what this class is using. We have a namespace, which I don't actually think we need, because we could just do this and import this, and this will work fine. So we can cheat there. And then we need this on every single proxy, and we need this on every single proxy, and then we need the methods. So it's 3 steps. Find and write all the using statements, find and write the class declaration, so the type name, and what we're implementing, and then use the dictionary, constructor, intercept method, and the example method, which is what we implement from the example. Okay, so having that, I think I can dive into the implementation. So for this to work, we do need to also keep here a private read-only dictionary of string and func object. And that's because we have to temporarily store all the method interceptors somewhere until we materialize the class. So we're gonna use that, and I think I can just for good measure, let's just store the type info, which is the beefy version of the type object. Especially for things using reflection, it makes things a bit faster if you store it. So t get type info, so we're gonna store it here. And oh, actually, now that I'm thinking about this, if I use a func for the method call, and let's rename this method call, then I can't really get the method information because it's already a func. But if I change this to an expression that returns a func, and then I will be able to get that, because the method call will have a body object, which the function doesn't have, which is the expression, and I know that the method equals body can actually be cast to a method call expression, because this will only be used for method mocking. So we know that this is what the body will be. And then I'll get the method name out of that, and I can do that by doing method dot method. Poor name here. It's not really a method, it's a method call expression, whatever. And then name. So this will give me the method name, which means then I can just do method interceptors, and then method name equals to a parameterless lambda that returns the result. And that's all I actually need to mock the method. And then to activate it here, I need something that effectively I will cast at the end to the tmockable, because we're going to use reflection here. And I'm going to use the activator class. So activator dot create instance, and then I'm going to say create type, or maybe generate type, but let's leave it to create type. And the parameter for that type will be the method interceptors. And we do this because, like we can see here, we require the interceptors as a constructor level parameter. This create type doesn't exist, and I'm going to create it now. And I'm going to return default, so compiler doesn't go crazy on us. And this create type method is where all the magic is. A few things that we need. First, we should just store the type to create. I mean, we already have the type info, but let's for now just store it here. So type of tmockable. And let's start writing the source in a string builder. When I mean source code. I might actually just rename this to source code. And I don't know if you actually understood this already, but we will in fact just write the text. So this will be just string concatenation, well, appending using a string builder, because strings are immutable, but you get the point. We are actually going to write this dynamically based on what we're mocking. So the new type name will be the type.name, and I'm going to put a proxy at the end. So that will be what my new class will be named, the one I'm going to be writing. And let me think about this. When the type full name, and I don't think we can get that, so let's just name. I'm going to use the type to create here. So what I'm doing here to get the full type name is I'm traversing all the declaring types of the current type to go as high as I can to do my, so this will be used, actually, let me just explain to you. This will be what I'm gonna use here. So we're just chaining to get the full version of this as if it was my, or actually mock library dot test dot example. So this sort of thing. So we're gonna get that. And then we need to get all the types that we reference in the class so we can get the using statements for that. And I think we can do that by simply, so this will ensure that I'm only mocking methods that need to be mocked, and that's abstract or virtual. In an interface, these methods are both abstract and virtual. So this will also catch abstract classes with abstract methods. Then I simply need to select the return types, and then I'm gonna concat also. And now I have the reference type. So here we just start writing, and we're gonna start with some that we won't get through this, which is the system itself. So using system, which I think we need, yes we do. We also need collection generic for the dictionary. So let's do that. Then we need it for the type that we're creating itself. So change that to this using type to create dot namespace. And then of course for the namespace of the current type. So we can do that by doing get type dot namespace. And now let's just write the reference types as well. And that should be all my using statements. So what I'm gonna do is I'm gonna stick a breakpoint here. Actually not here, this will blow up. I'm gonna just do it here actually, before it blows up. And I'm going to run the test and show you in the debugger what we've written until now. So let's quickly do that. So if I check on the source code and I do a toString, you'll see that we have all the using statements written here. We have system twice, which means I probably don't have to actually include it myself. I don't think the compiler will be mad about that, but we'll see. Okay, so we're getting there. Now what we need to write is this part and then this part. So we can easily do that by just doing, and that should give me this line here. And then the next step is to add the dictionary. And in fact, I can just copy paste that because it's going to be the same. So let's just do this so I can single line it. Oh, and I need this as well. Okay, cool. So where was I? And I don't think there's anything I need to change here, so I can go ahead and copy the next line, which is this. And there is something I need to change there. So I need to escape that and that. And then this needs to change to new type name. And then we have this method, which I can smush into one line because it's going to be the same thing. And with that, we've written all the way to the generic repeatable stuff. So now we need to find a way to write every method that needs to be mock. And let's see how we can do that. We do already get all the mockable methods. So I wrote this to return the mockable methods. So I can just iterate over them and say for each mockable method, and I need to invoke this, have a write method, which accepts the mockable method and the current source code, so we can append on it. So let's go ahead and create that. Now, what does a method consist of? It has, and then the type that you return, so the return type, the name, potentially parameters if they have any. In this scenario we don't, but we want to cater for that. And then we have this intercept method with a method name, so this will be the same always. And then the type that we're casting to return, and that's it. So I think I can do this. Let's go ahead and start writing this. Since void isn't a real type, I think we have to manually handle that, because otherwise it will have, I think, the capital void which exists in the system. I think I've seen this before, so you have to do that. The reason why we do this is we're getting the type code from the return type to use in the primitives. I'll show you down, but it's for safe casting versus hard casting. I'll show you where we use it. And this will basically just check if it's the last parameter to put a comma or to just end it there with a string.empty. And then each method has a parameter name and then, sorry, the parameter type name and the parameter name, and we need the space here. And that's how you write all the parameters. And then of course we have to close that. So we're missing this and this bit. So let's go ahead and write that. So I'm going to escape this and I'm going to put the method name here so it can match on the check. And here's where the type code check is coming. So if type code is object and the return type name is not void, and we don't want that here, then what we want to do is we want to hardcast. Actually, what we want to do is we want to safecast, not hardcast. Else we just want to hardcast. And we just close it with a curly bracket, and that's it. And now at this point, let me just run the test again and see what we have. Oh, I added it in my text, but I didn't add it in my actual code. That's unfortunate. So let's do this again. So source code.toString. Let's see what we get. Definitely not pretty, but we have the using statements. We have the class implementation. We have all this private and public stuff. This looks fine. We have the intercept method and return if it's not, else invoke it. So this looks fine. And then, wait a second, public system example method. What? That doesn't sound right. What did I do? Public, huh? Did I do the wrong thing here? Oh, of course, I'm doing namespace. I need name. Okay, so if I do that, then it should be fine. Let's check again. Yeah, that's more like it. So we have the string. So that all looks good. The last thing left actually here is to just compile during runtime and export the type and return it. So I'm gonna get the compiler that I have from the other project, the assembly compiler. So I'm gonna say new assembly compiler dot use reference of t mockable, so it can add the references from that type, and then we're gonna get the assembly, which is compiler dot compile, and we're giving it the source code to string, and we're giving it the assembly name, which for that we can just use the type to create. Actually, not the type to create. Is it the type full name? It's the new type name. Let's use that here, and then simply do, once it's compiled, return assembly.export the types dot first, because I think it's only going to have one anyway, or at least one. And I think that's it actually. So if I go back, if I actually first delete this example proxy, so now we have nothing in this project implementing this. You can see implementations, or when I'm doing this, implementations so for example were not found. Nothing in my project is implementing that interface. So what I'm going to do is I'm going to just run this test and potentially see it fail. Okay, it did fail. The code did not compile. Let's see why. So I have in my assembly compiler, I have this compilation error step. Where is it? It's here. So let's take a breakpoint and let's run this test again and see why it did not compile. So 2 errors. Missing curly brace. Of course it's a missing curly brace. Okay, where am I missing it? Let's try to get the source code. Oh, it's out of context. I have to stop and start this again. It's always the curly braces, aren't they? So if I run this and if I try to get the string, open that, I'm not gonna look, I'm just gonna copy it and I'm gonna create a new class and I'm gonna paste it here. So example proxy. Is it the last one? Oh yes, it's just the last one that is missing. So if I delete that, why do you not like me deleting that? Huh? Sorry, I had to restart right there because this made it glitch out. So where was I? We are missing the last the last semicolon. So I can go ahead and add this here. So source code dot append line this, and this now means that our class is compiling and this test should pass. So without any further ado, let's just run it. Yes. So let's see what's happening on the debug level. Our test just worked. There is no implementation, I'm repeating, of this interface in the project. If I try to find implementations, nothing is found. So let's see how this works. First, and I'm gonna go back to the test. First, we're creating this my mock class, which is fine, simple enough. And then I'm going to the mock method, and I'm stepping in the method to see that I'm getting the body of the, in this case, an instance method expression. And now that I have the method with all its code and tree, I can just get the name and then put my mock result as a method interception level. And once I have that, I can use the object, which will materialize this by using the activator class to create dynamically the instance. And how it's going to do it? Well, first it's going to get all the reference types found in my in the class that I want to build and use them for two purposes. The main one is actually, it's only one purpose. It's to implement the using statements. And if you see what my source code looks like at this point, it's just all the using statements I want. This will create a warning because I have system twice, but I have it here just in case. And then what I'm going to do is I'm just going to write the top level of the method, then write every single mockable method, and then compile it. It's not the fastest thing to compile, but it works. And then, I just pressed F5. That's my mistake. But if I do this here and show you the class that we created during runtime, this example is an iExample proxy, which only has method interceptors, and it knows what to effectively mock this with. So if I simply do this, I get hi by mock because it's using this in-memory implementation. So I think that's actually how they do it. They might be doing it way more efficiently than me, and I'm sure that if I throw things like generic type parameters, this will go boom. I'm not going to try it. I want to prove the principle. Let's see what happens if I add a second method. So let's return a number, magic number here. And this also accepts an int my number? Yeah, whatever. We're not really going to use that. What I want to do though is I want to mock that. So let's go back to the test and create a separate test. Same code, should mock again. And instead I'm going to mock the magic number. And I'm just going to put some random number here because I can't really do the arc.any that mock is doing. I don't have this implemented, and it would take probably way too long to implement for me here. But I'm getting this 1, 2, 3, 4, and I'm gonna return 4, 3, the wrong button, 4, 3, 2, 1. So all I want to do is I want to check that this magic number method will return this. So if I go ahead and run this, let's see if the test is passing. It is passing. So now my class is written with two methods, not just one, and it's only mocking one of them. And if I run both of them, I'm sure they're both going to pass. So you can see mocking without any implementation. So I think that's it, everybody. This is how you can get started with this. I hope you at least find this mildly interesting. I find it very interesting to take things that I use and take for granted every day in programming and try to see how they built them. How did they do it? Can I crack it out? Can I crack the code and build it myself? And I'm gonna go ahead and call this a victory. I think this is how the foundation of such a process can go, but it can get optimized, I think 1,000 times or more, and potentially get way more flexible. And that's why we have these pre-made solutions from years and many developers of work for us. And we should be thankful for that, because this actually is very, very hard to do. Something I should mention is that you really shouldn't expect to know any of that reflection stuff. It's definitely not required from you. I like to play with reflection a lot to see how I can push it. So that's probably why I was able to know some of these write method and stuff, and the assembly compiler, which I already had. You don't have to know any of that to be a good C# engineer. So don't worry about that. Don't see this and think that you need to know any of that. That's all I had for you for today. Thank you very much for watching. Special thanks to my GitHub sponsors for making these videos possible. If you want to support me as well, you're going to find the link in the description down below. Leave a like if you like this video, subscribe for more content like this, and ring the bell as well. And I'll see you in the next one. Keep coding.